Welcome everyone. This is 14.4 on perpendicular lines. Remember that perpendicular lines, the definition of perpendicular lines is two lines that intersect at a 90-degree angle. Easy. So it's that. So if these are the two lines that intersect, they will always create a 90-degree angle, and that is the representation, the little box is the representation of a 90-degree angle, right? Everybody knows that. But there are a couple of things. One thing, essentially, that we have when perpendicular lines are, or two lines are perpendicular, okay? If a point is on the perpendicular bisector, so it's perpendicular and it bisects the segment, right? So line M, the vertical line here, right? This line here is the perpendicular bisector of segment AB, right? Of that segment there. So how we represent that is this 90-degree angle here, right? And that they are bisecting, which is the little tick marks. So we know if this point is, let's say, Q, we know AQ is congruent to BQ and angle PQB equals 90 degrees, right? Measure of angle PQB is 90 degrees. If we know that, this theorem says then it is equidistant to the endpoints of the segment, which means if I draw out PA and PB, they are congruent. Okay? That makes sense? If I know the purple, then I know the red. Okay? So if I know that, and if I have this question, use the diagram shown. BD is the perpendicular bisector of AC. So if BD, this perpendicular line here, is the perpendicular bisector, this guy here is a perpendicular bisector of this. This already showing it to you that it's a 90-degree angle and they are congruent, right? Then automatically I know that they have to be equal to each other as well. And they have to be equal to each other as well. Okay? Notice that the tick marks are the same. The same number of tick marks means that they are equal, right? So suppose ED is 16. I want to make these guys a little bit smaller. Okay. ED is 16. DA is 20. Find DC. Well, if DA is 20 and it has two tick marks, DC has to also be 20 because that too has two tick marks. Simple. We didn't even need 16, right? Make sense? Okay. Number 5, EC Where is EC? EC is 15. So I don't know what I'm looking for, but AE is 15 as well. BA is 25. Find BC. This is also 25. Yeah. Simple. Easy. Questions? What are they? No questions? Okay. So we just went over if a line or a segment is on the perpendicular bisector. So if we have perpendicular and bisector, right? Then we know that the two segments, AD and CD, are also congruent, correct? If we know that. The next one is the converse to it, which is also true. If I know that I have a line here, right? I have a point. Let's call this point C. And I have a segment here. Let's call this A, and let's call this B. And I know that that, okay? I know AC is congruent to BC. Then I know that C, or this line, is on the perpendicular bisector of that segment. Okay, the converse to it, right? The segment. Okay, so if a point is equidistant from the endpoints of the segment, that is blue, right? In this example here, that is telling me that if I know AC is congruent to BC, then it lies on the perpendicular bisector of the segment. So I know, I'm going to label this point as well, point O. Then I know AO is congruent to BO, and the measure of angle COB equals 90. Okay? Vice versa, right? The converse to it. All right? Cool. So if AD, we have this, if AD is 10 inches long, so this is 10, BD is 6, find the length of AC. So since you're given that these guys are equal, I know point D is on the perpendicular bisector, right? DB is the perpendicular bisector of AC. So I know that these guys are equal, and I know that this is 90 degrees, right? So that's what I knew so far. And that's 10, that's 6. So what is AB? I have a right triangle. I have a right triangle that looks like this. 6, 10. Yeah.
Doesn't AB have to be 6 too?
No. But I know it's a right triangle. So what theorem do I use? Hint, it's none of the theorems that we went over today. Yeah. Yeah. Oh, I made this whole thing up and then you're gonna, yeah, it's the Pythagorean theorem. Yeah, the Pythagorean theorem, right? Which says a squared plus b squared equals c squared, right? So if a squared plus b squared equals c squared, and remember that it doesn't matter what your a and b are or what you place as your a and b. The only thing that matters in this set in this thing is c. Okay, is c. C is always going to be your longest side. So as long as you set that as your longest side, 10 squared, and you know it's your longest side because it's always going to be across the 90-degree angle. Okay? So that's 10 squared. I don't care where I put 6, and I don't care where I want to label that x. Where I put my x, it can be x squared plus 6 squared. Okay? That's 100. That's 36 plus x squared. Subtract 36 on both sides, you get 64. So x equals 8. And square root both sides, right? Yeah. We're good with that math. So that's 8, right? AB is 8. I gotta figure out what AC is, but since 8 has 2 tick marks and BC also has 2 tick marks, that's also 8. So AC is then gonna equal 16. 8 plus 8, 16. Okay, cool. Questions? Simple, right? Ooh, what is this? We're given that B or line B is parallel to line D. Line C is parallel to line E. Measure of angle 1 is 50. Measure of angle 5 is 90. Solve for angle 4. Okay. We have two sets of parallel lines. Instead of just solving for angle 4, I want to solve for everything. Okay. I want to give you guys all of the angles. Since this is 90, and I want to make 90 a square, right? This is also 90. Why is that the case? Because they're vertical, right? They're vertical angles. And since this is 90, this vertical angle here, this vertical angle here is 90. It also corresponds to this angle here. So this is 90, right? If you look at line BD and use A as your transversal. Okay? If that's 90, if this one is 90, then this is also 90 because they're vertical. Cool. Now, line C, I'm going to draw line C here. I'm going to draw line E here. I know that they are parallel, right? Yeah. I'm going to use the same transversal. That's my transversal A. This is line C and line E. I know that this is 50, right? Angle 1 is 50. So what is angle 2 equal to? 50. Because they're corresponding, right? Okay. 50. So if angle 2 is 50, what is angle 6? No. 40. Why is that? Why is this guy 40? Huh? Because they add up to 90. How do I know that 2 plus 6 equals 90? How do I know that? No, it doesn't say it bisects, but it does. No. Yeah, it has to equal 180 because angle 5, angle 2 plus angle 6 has to equal 180 because they are linear pairs, right? And so then this guy has to be 90 as well. Yeah. Same thing up here. This is 90 and this is 90. So this is 40. And then we're going to use vertical angles to get angle 4. This is 40. And this is 50. Yeah. This is 40 and this is 50. Cool. Yeah, I just got it, all the angles. Okay. All right. And that is the lesson for today, class. Yes. Angle 5 and angle 2 plus, so angle 5 and then plus the sum of angle 2 plus angle 6. They are linear pairs. Okay. All right, so there are a pair of angles, two angles that add up to 180 or that make up a line, right? All right, so that is the lesson for today, class. Thank you so much.